So, I'm going to expand this thing here. It's slightly more complicated because it starts with a 4 rather than 1, and we can't expand that kind of approximation unless it starts with 1. So the first thing we need to do is take a factor of 4. And we end up with that thing there. Same thing, but notice I've put the whole thing inside the bracket to the power of a half. What some people do is they say, okay, factor of 4, they take the factor of 4 outside, which is great, but then they forget that that 4 needs to be to the power of a half as well as the other thing, and that can lead to some errors. So we end up with 4 to the power of a half times by 1 plus x over 4 to the power of a half. Hopefully we all know 4 to the power of a half is 2, it's a nice whole number, and then we can do the expansion of 1 plus x over 4 to the power of a half. Again, I'm using 1 plus x to the n is equal to nx, 1 plus nx plus n minus 1 over 2 factorial x squared. In this case, 1 matches up, so the x is replaced by x over 4, and the n is equal to a half. So we get 1 plus a half x plus a half times by a half minus 1 over 2 factorial. That x should have been an x over 4, so I've messed that up. Let's go back and change that. X over 4 squared. And then again, as it was previously, it's just a case of evaluating the fraction. So a half of x over 4 is x over 8. A half times by minus a half is minus a quarter. Divided by 2 is minus an eighth. Divided by, well, times by 1 over 16 is minus x squared over 128. And again, that series would continue on forever. So 4 plus x to the power of a half is equal to 2 times by all of that, which gives 2 plus x over 4 minus x squared over 64, and again, that will go on forever. So, mistakes there, I made it myself. I forgot to replace the x with the x over 4. To evaluate these, again, just recalculate it, just do a half times a quarter, it's an eighth, and again you can stick all of that into your calculator. A half times by a half minus 1 over 2 factorial times by 1 over 4 squared. Stick in the calculator and you should get the right answer for that. So that effectively is part A. Slightly more complicated because of the fact that we need to take that factor out. And again, just to reiterate, don't forget that whatever the factor is, you need to put that to the power of the expansion as well. So in part B, sorry, yes?
What was that thing you just said just now?
So what I'm saying is, don't forget when you take that factor of 4, that this has to be to the power of a half, along with the other bit as well. As I say, people will often forget that extra power there, and it'll lead to an incorrect answer as you go down. So in part B, we've got x equals 1/9. And again, as we've done previously, swap it throughout the expansion and see if we can end up with what we're after, which is the square root of 37. So we have 4 plus 1/9 to the power of a half is equal to 2 plus x, which is a 1/9, over 4, minus x squared, which is 1/9 squared, over 64. 4 plus a 9th is 37/9. The power of a half means square root. So I've got my square root of 37, nice. Square root of 9, again, it's just a whole number, we can evaluate that straightforwardly. And then on the other side of this bit here, if you evaluate all of that, you have 2 plus a 9th divided by 4 is 1/36. Then you've got minus. Sorry? Because if you do 4 plus a 9th, 4 9s are 36. So that's 36/9 plus 1/9, 37/9. But you just put in the calculator. What do we have? So 2.
My calculator won't let me square root 37/9.
I don't want you to. That's the last thing you should be doing.
I know, but why wouldn't it let
You need
me?
to square root them individually.
Yeah.
So
Your calculator should let you do it.
3
Why
and you
would-
times it by 3.
Yeah, I know, but I
exactly.
understand why we didn't do it.
Well, let me just have a look at your calculator's foibles in
Oh,
a
it's
second.
done it.
It has, is it? What was the problem then?
Oh, I don't know.
Just turn it around. Yeah. So you end up with. Which means that we end up with the square root of 37. So the square root of 9 is equal to this thing here. And then if I multiply across by the square root of 9, which is 3,
Oh, what's something different?
you get something different. Where have I actually got something different?
So if I do the right hand side, 3,449 over 1,700.
Have you got a minus there rather than plus?
Yeah, minus.
Okay. Let's check then. So, I'll do it again. 2 plus 1/9 divided by 4. It depends how you put that fraction in your calculator sometimes. Right, so what I'm going to do is, rather than do a fraction over a fraction, which complicates things horrendously, I'm going to do 1/9 divided by 4, which is the same thing.
Is it the whole fraction squared, that last one, or is it just the 1/9?
Just the 1/9 is the thing that squares. So minus, open brackets, 1/9 squared is 1/81. Divided by 64.
Yeah, I got what was the answer.
You got my answer?
Yeah.
I'm sorry, you're adding one.
Yeah, I think, whilst maths isn't a democracy, we seem to all have agreed, apart from you, Vivara. So I'll come and have a look, see how you put that in your calculator. And again, checking the accuracy of that one. So, again, the question's not asking for it, but doing it. Square root of 37 is 6.0827. Again, in an exam situation, if you have got time left to check these things out, if the two things aren't close to each other, then the chances are there is a mistake. So if when we do this, we get something which is nowhere near that, then we'll know there's something probably wrong. And on the calculator we've got 6.08275546. So looking at that, the first 1, 2, 3, 4 decimal places are the same, which means that if we did that percentage error thing on that, it's not going to be very, very big at all. It's going to be minute, like in the, certainly, well, probably less than 0.1%.